Hi guys and welcome to this, our 2021 VCAA Further Maths Paper 2 Work Solutions. These are my suggested solutions. I don't have access to the actual solutions, but I am incredibly grateful to a number of people who I will quote and sort of reference in the descriptions who have jumped in and helped just allow me to check or group check our responses. If you can do me a favour please and subscribe, turn off notifications. By all means turn off notifications, but if you can subscribe, it just lets me know that you watched this video. I really greatly appreciate it and like it. Please like the video, because YouTube once again have changed their algorithm, and so it's likes that apparently get people to come to the channel, and all I really want to do is help people. All right, so again, last thing from me before I start these answers is, if you can, send out the word to your mates, to your year 11 friends, teachers, schools, and just tell them not only about my channel, about mathsguru.com. I'd be really grateful. Yeah, so many people turn around each year and go, oh my god, if only I'd found your channel earlier, you know, you guys, I am one person, you're brilliant, and blah blah. I just want people to actually get out there and hear. Now, what am I going to do for these videos? Basically below you will see there is the orange caption that will tell you very much what question I'm working on. I'm going to do both core and module solutions, but I'm going to try and cut down the calculator stuff if that's okay, simply because it just makes the video a lot shorter. Right, data analysis. In the sport of heptathlon, athletes compete in 7 events. They are, and you were given basically a table of information there. You were given high jump, shot put, and javelin. He says, with no answers in front of him, so let me grab my answers as well so that I can look through them as I'm doing them. Right, the first question, write the number of numerical variables in table 1. Numerical variables, well, basically anything that can be measured. And in this situation, high jump, shot put, and javelin are all numerical. Athlete number is actually categorical. You can't have an average athlete number. Doesn't make any sense. So write down the total number of numerical variables. The answer, as far as I'm concerned, is 3. Then goes on and says, complete table 2 below by calculating the mean height jumped for the high jump in meters. Now, what did I do there? Well, I went to my high jump and I entered all of this data into my CAS calculator. And again, for brevity, I'm not going to do that. But then, having got that information into my calculator, I basically did menu, statistics, and I did an analysis, and I did a single, I can't remember what it's called. Basically, I just did an analysis, and it came out with the information that I actually needed for this question here, which gave me a mean of 1.81 meters. Okay. In shot put, athletes throw a heavy spherical ball as far as they can. Athlete number 6, Jamila, threw the shot 14.5 meters. Calculate Jamila's standardized score. Now, because we're dealing with shots put, that basically means we need to use this information here, because when it's talking about standardized scores, it's talking about a Z-score. And we know that Z is equal to the actual score minus mu divided by sigma. So we needed to know the mean and the standard deviation for the shot put. Well, we told it was 14.50. I'm going to take away the mean, which was 13.74, and divide that by 1.43. Now again, because it wanted the answer rounded to 1 decimal place, and again, be very careful there, then we worked out on my CAS calculator that came to be 0.5. In the qualifying competition, the heights jumped in the high jump are expected to be approximately normally distributed. Okie dokie, normally distributed. There we go. Ka-ching, 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 ka-ching. Chara's jump in this competition would have given a standardized score of -1. Now, there's lots of ways of doing this, but basically I know that a standardized score of -1 is basically on that line as well, right? So a Z score of -1 means it's 1 standard deviation to the left. Use the 68, 95, 99.7% rule to calculate the percentage of athletes, not the number of, who would be expected to jump higher. So because we want it to be higher, we are basically looking for this area here. Well, what do I know about this area? I know that this section up to here is 50%. I know that this section here is 34%. And so when I add those two together, it gave me 84%. The box plot below was constructed using the distribution of high jump heights for all 15 athletes in the qualifying competition of the high jump. Explain why the box plot has no whisker. Now, when I put the data in from the high jump, and you'd already had that in, then what I ended up doing was I'd noticed that my highest value was 1.87. And I know that my Q3 from my calculator was also 1.87. So they were effectively the same value. And so I suggested, or I wrote, what did I write? So there we go. Again, as Q3 or my upper quartile is the same as the maximum value, there is no whisker at the upper end. For the javelin qualifying competition, another box plot is used to display the distribution of ERRATA. As now, I think this question was a bit of a trick because yes, and I know there was discussion on there. It said you wanted to work out the interquartile round. Now again, I got all of the information from my for the javelin. Well, actually, I think the first thing was you had to go back and put the information in for the javelin. And I saw something on Reddit recently that said it was upsetting that we had to keep writing all that data in. I get it, and unfortunately, speed was of the essence here, or speed and accuracy. So when I put that data in, I got Q3 was 42.88. I got the IQR to be 42.88 minus 40.88, right? So that was my value of Q3, just right off my calculator, which gave me an IQR of 2. So therefore, I knew that my upper fence was equal to 42.88 multiplied by 2 lots of 1.5, sorry, plus 2 lots of 1.5. Let's make that a bit clearer. Which gave me 45.88 meters. Now, this is where I think the trick to the question came in, because, you know, you can't just put 45.89. This value is the highest value, all right? And I think it includes. So any value higher than that will give the potential to be a medal winner. So I have written, my exact answer would be, therefore, a value above 45.88 meters. Yes, I don't know how you could be specific there, and I don't know, maybe VCAA will give the answers to any value that's higher than 45.88. I don't know, but I have a feeling they're looking for something a little bit more specific. All right, question number 2, a least squares regression line. No, hold on. The two running athletes in a heptathlon are the times taken are given when a least squares line is fitted to the data. Right, round the values of the intercept and the slope to 3 significant figures. I know for my own group that significant figures is something that tends to throw them. All right, so basically for time, I would have had 0.0393, and then that rounded to, what is it, 3 significant figures gives me 5.28. All right, so again, 1 mark for being able to round. There's always one of these questions on here. The mean and the standard deviation for each variable time and time are shown in the table below. The equation of the least squares line is given by that. Now, again, another one of these questions come up all the time, that when they give you the equation of the least squares line, we know that basically this value here, which is, if you have the equation in the form of y equals a plus bx, we know that that value there is given by, so the value of b is given by r times sy over sx. Right, that's one of those formulas that I tell my guys to write in all the time. So that value was given to me as 5.2756. That becomes r, which we're trying to find because it wants us to find the coefficient of determination. Well, it actually wants us to find, wants us to find the coefficient of determination, we have to find r first. So they gave us s of y. Now again, we had to make sure we chose the right one, which was that one there. So that becomes 8.2910 divided by 0.96956. Now when I did that in my calculator, I got a value of r as 0.61693. That was my coefficient of, that was called my correlation coefficient, but I wanted my coefficient of determination, he says. So r squared became equal to 0.380609, and because it wanted it to the percentage, right, that would give me that r squared would have been 38%. How did I do that? Multiply that by 100 and round to the nearest whole number. So r squared in that value there was 38%. Question number 3, the time series plot shows below the winning time in seconds for the women's 100 meters freestyle swim plotted against year for each of the Olympic Games. Okay, a least squares line has already been fitted. Thank you very much. The equation of that least squares line is The coefficient of determination is, here we go, coefficient of determination. Name the explanatory variable. I'm going to be honest, guys, I thought that was quite nice of them. The explanatory variable is the one that's on the explanatory x-axis. So in that situation, that gave me year. And then it went on to say, determine the value of the correlation coefficient R. Now they gave me R squared value. So what I needed to do was put that into my calculator. Let's do that now. So I can do the square root of 0.8794. That gave me, now again, the trick here is, and I do it all the time, guys, is remember your calculator, when you do that, you get both the positive and the negative value. R squared or the square root can give you a plus or a minus value. And because my data is sloping down, then basically I know that I have to have the negative of that. So 0.9378, okay? Write down the average decrease in winning time in seconds per year. Well, that was really asking you just to read off this value here, which was the gradient. So that was 0.1515. The predicted winning time for the women's 100 meters freestyle in 2000 was 54.10 seconds. The actual winning time was given. The residual, well, I know that the residual is the actual value minus the predicted value. So that gave me 53.83 minus 54.10, or negative 0.27. Again, yep, that was my answer. No rounding required. The following equation can be used to predict the winning time for the women's 100 meters freestyle in the future. Show that the predicted winning time for the women in 2032 is. So in which case I just said the predicted winning is equal to 357.1 minus 0.1515 times the year, which was 2032, and that basically gave me 49.252, which is what the question was effectively asking me to do. And I'm going to be honest with you guys, I know many of you didn't like this paper, but I think up until now it's been quite fair. It gets harder, trust me, I know that. And I know a lot of people were very upset about the length of time that the questions took to do. We'll come back to that in a moment. What assumption is being made when the equation is used to predict the winning time? Guys, the weird thing is a lot of these questions felt very familiar. And the reason I know that is because I'd actually just previously recorded the 2021 Northern Hemisphere paper. And it's surprising that the reason I'm writing the answer that I'm writing now is because it was exactly that question, pretty much, just different numbers. Okay, so basically the answer from VCAA for the 2021 Northern Hemisphere, we just talked about the trend line continuing, so I just modeled that response. The trend line continues in the same way as years increase due to extrapolated data. Something along those lines. Just talk about the trend line continuing in the same way. You're given a time series plot showing the winning time for both men and women in the 100 meter freestyle swim in the Olympic Games has been decreasing during that period. Okie dokie. The least squares line to use to model the trend for both men and women was given. Draw the least squares time for the winning time for women on the time series plot above. So because we were doing women, I highlighted that. Now, again, when you're having to draw this, you've got to draw it accurately. So I went and basically put 2 years in here. The whole point of it is you can put years into that equation and you can come out with actual data items to plot. So I put 1908 in. So for my first point, I did 538.9 minus 0.2430 times, what did I say, 1908. And so putting that into my calculator, I will do this one, 538. He says 538.9 minus 0.2430 times 1908 gave me 75.2. So when I went up here, 75.2 was roughly speaking around there. And likewise, when I did my next data item, it gave me about, he says, 43 point something. Let's just do it, just change that to 2020. He says, moving all his paper out of the way. Delete, 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 delete. 2020. Yeah, 48.04. So again, I went to about 48, which was roughly speaking there. Drew my straight line between them. And there we go, there was my regression line put on there. The least squares lines. Oh, we've already done that one. Try again. Oof, I'm losing the plot. The difference between the women's predicted winning time and the men's predicted winning time can be calculated using that formula. Very nice for them. Use the equation of least squares line on page 8 and the formula above to calculate the difference predicted for 2024. So again, I put 2024 into both of these equations, right? So here, I changed that for 2024 and worked that out. And here also for 2024 for that equation as well. Now when I did that, I got my value of men's to be equal to 44.3944, I believe. And for the women's, I got 47.068. Therefore, the difference, and we had to make sure you took them away correctly, was equal to 2.7 seconds. Now, I always write the units, to be honest with you. I know they give them to you in the question, but I always write the units just to make sure. Yes? So, again, where would you get the 2 marks there? One for the question, probably the one for the answer, and maybe one for the working out, which I've effectively shown there. C was a trick question, all right? And it tricked me initially, and I was like, hold on a moment, why is that in bold? And then I worked it out. So, basically, we're trying to find out for the first time that the winning time for women will be faster than the winning time for men. Now again, this was another carbon copy of the 2021 Northern Hemisphere exam for further maths. Literally, they just changed the numbers, or very similarly. So I was like, oh, okay, so in this situation, let's solve for when the times are the same. Right? We will solve for when the times are the same. And all I did there was put the 2 equations together. So I put 356.9 minus 0.1544, and I called the year equal to x. I put it equal to 538.9 minus 0.2430 times x, and I just put that into my calculator and I just solved it. Now what came out of my calculator was 2054.18, and I think many of you may have been tricked by thinking, oh well, it's 2055. That wasn't an Olympic year. Again, they actually also told you what the Olympic years were. And if you remember, you had to keep adding on 4. So again, what I put into my calculator was 2032. I kept adding 4 until I got to the Olympic year that was the closest. And actually it turned out that the answer was, therefore, Olympic year was actually equal to 2056, okay? Oh, tricky. Question number 5, method for predicting future time differences in the 100 meters freestyle swim was given by that again. The resulting data and the time sequence plot was shown. The plot is clearly non-linear. Okay, I'll take your word for it. Apply a reciprocal transformation to the variable difference. So when it's a reciprocal, it's 1 on the difference is equal to, and again, I put that data in, I made sure that I had the year and the difference. Again, I'll do these questions later on in another video maybe that shows you specifically how to do that, but hopefully by now you do know how to put this data in and do a reciprocal transformation. Having put the data in, having got my 1 on y, I then basically pressed a few buttons and said, okay, can you tell me then the equation of the least squares regression line? And out came minus 2.234, and again the question was quite clear, 4 significant figures, plus 0.001209 times the year. And I'm going to say now, guys, if you've used the values of x and y there, you're going to lose your marks. All right, you may get 1 mark for the correct coefficients. I don't know how VCAA mark these things, but I do know that for SACs and stuff, we get a little bit upset if you don't actually give the correct regression analysis line, and you can't put just y and x. Even if your calculator says that, it's for you to remember what the x-axis and the y-axis was called. Use the equation from part A to predict in seconds the difference between the women's and men's winning time, okay, in 2032. So again, I'm going to show you what I did here. All right, so I'm going to put the value of 2032 into there. So it was minus 2. So putting that into my calculator correctly that time with the 2.2 whatever gave me that my 1 on my difference was equal to 0.222688 ... And then all I had to do was basically do the reciprocal of that. Yeah, so I just did 1 divided by my answer. It gave me 4.5. So the difference became 4.5 seconds. All right, again, tricks there with the 1 over. So again, I hate to say this because people can get angry at me, and I don't mean that to be, but yes, there was a lot of data entry in here and time was of the essence, but I don't think there was anything in there that was too out there. All right, that comes much later in the modules, to be honest with you. Okay, now we can move on to recursion and financial modeling. Sienna invests $420,000 in a perpetuity. Perpetuity, basically the value doesn't change because you live off the interest. She'll receive regular monthly payments of that. That's my interest effectively. The perpetuity earns a rate of that per annum. Determine the total amount of dollars that Sienna will get after 1 year. Well, if she's receiving $1,890 per month, there's 12 months in a year, multiply those together, gave me $22,680. Write down the value of the perpetuity after she's received 1 year of monthly payments. Well, the thing, the perpetuity is the value doesn't change. You live off the interest. And so in that situation, you still would have, or Sienna still would have had, $420,000. Let S be the value of Sienna's perpetuity after n months. Complete the recurrence relationship in the terms of that, that, and that. All right. So S0 we already know was 420,000. What we needed to do was work out the interest as a multiplier. So because it was 5.4% per annum, we weren't compounding monthly. So I did 5.4, no, because it's monthly payments. So that 5.4 was per year. I divided by that by 12, that's percent, divided by that 100 to get my multiplier. And because it's interest, it's growing, I've added the value of 1 on, and that gave me 1.0045, all right, times the 1890. Sienna owns a coffee shop. A coffee machine purchased for $12,000 is depreciated using the unit cost method. The rate of depreciation is 5 cents per cup of coffee. The recurrence relationship was given below. Calculate the number of cups of coffee the machine produces per year. Because my coffee depreciates by that much, then I can do 1440 divided by 0.05. Now they're actually quite nice to you in this one here because normally they give you a change of units or a mixed units. They would normally put that down as 5 cents, but I think they were trying to be a little bit nice to you. And when I did that on my calculator, I ended up with 28,800 cups of coffee. Cups or cops? Cups. The recurrence relation above could also represent the value of coffee machine depreciating at a flat rate. What is the flat rate percentage? Well, we know that it's depreciating by $1,440. We know that it started at 12,000. And when I multiply that by 100, I'm going to end up getting 12%. All right, so it's the year depreciation divided by how much it started times by 100. Now, I'll be honest with you, this next question I was like, "Khe?" But it was a trick. Complete the rule below that gives the value of the coffee machine in dollars after n cups have been made. We know that the value of the machine started at 12,000, and we know that it's going to depreciate by 5 cents for every cup of coffee, which is n. So actually that value there should have been negative 0.05. And I know some people were like, ooh, that wasn't fair. No, it wasn't, but it's there to test your understanding. For renovations to the coffee shop, Sienna took out a reducing balance loan of $570,000 with interest calculated fortnightly. The balance of the loan in dollars after n fortnights. Sn can be modeled by the recurrence relationship. Calculate the balance of the loan after the first fortnightly payment is made. Calculate the balance of this loan after the first. So he says, moving his paper, 570,000. We're going to multiply that by 1.001. I'm going to take away 1193, which gives me the value of $569,377. So you just were really looking for the value of S1 because that was fortnightly. Show that the compound interest rate for this loan is 2.6% per annum. Well, having done something one way, we now get to do it backwards. So I've got my interest rate of 1.001. I'm going to subtract 1, which gives me 0.001. That's percent. All right, now that's per fortnight. I'm going to multiply that by 26 to give me a year. And that's going to then multiply by 100 to give me a percentage, which gives me the 2.6. And because the question said show that, you had to show your calculation, all right? VCAA are very, very clear on show that questions. Okay, for the loan to be fully repaid to the nearest cent, Sienna's final repayment will be a larger amount. Okay, so I used my financial solver here, menu 8.1. All right, so N, what was my value of N? The value of the row after M4 nights. Maybe a larger amount. Okay, so the first thing I did was find out how many payments there were going to need to be. So we knew the interest rate was 3.6% per annum. We know the principal value. She took out a loan 570,000. She was making payments of, she was making payments of 1193. The future value would be 0, and she's doing 26 payments per year. So if we now go to that, basically 650 payments. So I now know N is going to be 650 payments. So if I now change this to 650, and we do our future value, we get that she still owes $5.59. Now, again, I don't do it that way because you remember if she still owes for another month, she's going to actually make a payment. So I tend to do 651, go down to the future value, gives me $1,187, all right? So that's how much she's going to overpay. So I then did the $1,193 minus 1187.40, which gave me, so escape out of that, 1193 minus 1187.40 gives me $5.60. So really that's the excess that she's going to really have paid. So if I do 1193 plus $5.60 gave me $1,198.60. $1,198.60. Sienna invests into an annuity from which you receive a regular monthly payment of $900 for 25 years. The interest rate for this annuity is 5.1% per annum compounding monthly. Let V be, so show recursive calculations. Again, it says show recursive calculations. So what I did was V0 was equal to 152,431. All right, and let Vm be a recurrence relation written in terms of can be modeled, show the value. Okay, so I now know that to get my recursive and relationship, I've got to do that. So it was 5.1% per annum. So and it's fortnightly. So 5.1 divided by 100 divided by 12 and plus 1 gave me 1.00425. That was my interest rate times V of n, and then I'm going to minus 900. So there's my recurrence relationship. So now what I did was to show that, I did, well, okay, I'm going to do 1.00425 multiplied by 1.00, try that one again. Multiply that by 152,431 minus 900 gave me 152,178.83, and then V2 was 1.00425 multiplied by 152, where has it gone? 178.83 minus 900 gave me the value of 151,925.59. All right, so 151,925.59. After 2 years, the interest rate for this annuity will fall to 4.6%. To ensure that she'll receive the annual same number of $900 monthly payments, Sienna will add an extra one-off amount to the annuity at this time. Determine the value of the extra amount that Sienna will add. Okay, so what I wanted to do here was just work out how much she had after the 2 years. So she had investment of, so minus 152,431. The annual interest rate, or the interest rate, was 5.1%. Payment of, will receive a regular payment, so she's receiving $900. The future value is going to be 0, and that's going to be 12 and 12. Okay. So actually no. So what I want to do is after 24 payments, see how much she's got as my future value. And when I hit enter, I got, so after the 2 years, She had 146,073.74. Okay. Now, that's what she's got. But then the interest rate changes. So what I then did was say, well, how much is she going to need if she needs to still have that $900? So I went back up here and said, right, well, she's already paid off 2 years. There's 23 lots of 12 years left. So that's how many months she's going to pay. The interest rate now becomes 4.6. I'm going to work out the principal value, knowing that at the end of that time, she's going to have nothing left in the bank. And that gave me that she would need 153,112.94. That's how much she's going to need. That's how much she's got. That's how much she's going to need to continue those $900. And when you subtracted those away from each other, you ended up with $7,039.20. All right, now we move on to the modules, and I'm going to cover all 4 of the modules here. He says, I am a glutton for punishment. If any of the answers you think are incorrect, then do me a favor, leave a comment below. If I notice anything, then I'll do some errata. But again, I am 99.4% sure that all of these answers are pretty much there. Hey, matrices. Question number 1. Elena imports 3 bands of olive oil to the number of 1 litre bottles shown as that. What is the order of matrix? Again, I do 3 by 1. 3 by 1. It's unclear. I'm never really sure what VCAA wants. I keep asking them, but never get anything back conclusive. Maybe someone will let me know one day. Elena expects that in February 2021, the sales of all 3 brands of olive oil would increase by 5%. She multiplies matrix X by a scalar. All right, and write down the scalar value. Well, if you're increasing by 5%, what was 100% becomes 105%. As a multiplier, you divide that by 100, which would give me 1.05. The main computer system in Elena's office is broken down. Again, this question, no word of a lie, almost exactly the same as the one in the 2021 Northern Hemisphere. Main computer system, 5 staff members having problems sending information to each other. Matrix M below shows the available communication links between the staff members. Which 2 staff members can send messages directly to each other? To do this, what I actually did was I drew a line down here and I was like, okay, let's see what is symmetrical either side. And as it turned out, those 2 values were symmetrical. And so that suggested that Brie and Dex can show each other, can communicate to each other. And like I can do at the moment, I can't communicate. Elena needs to send documents to Chai. Okay, so Elena needs to send documents to Chai. Let's rub this out so that I've got something I can work with. What is the sequence of communication links that will successfully get the information from Elena to Chai? So Elena would have to talk to Dex. Then I go from Dex, and basically he can only talk to Brie. And Brie then has an option of, what would that be? Dex or Chai. Well, in which case, because we want to communicate with Chai, that there would give me my order. So writing that down, I would have Elena to Dex, to Brie, to Chai. Matrix M squared below is the square of matrix M and shows the number of 2-step communication links. One pair of individuals has 2 different communication or 2-step communication links. That won't be that one there. So what that means is that basically A can communicate with D through 2 different people. So A can communicate with D through 2 different people. And again, going back up here, let's rub this back out. A can communicate to D through. So A can communicate to D. Well, A can communicate to B and E. Can E communicate to D? Yep. Can B communicate to D? Yes. So basically A can communicate through both Brie and Elena. And obviously understanding two-step communication matrices comes in really, really handy later on. And that last question was horrible. All right, a market research study show shoppers preference for 3 olive oils, blah, blah, blah. The initial state matrix, S0 below, shows the number of shoppers who bought each brand of olive oil. The SN represent the state matrix describing the number of shoppers. How many of these 8,000 shoppers bought a different brand? Well, we know the number of people who bought each of the brands is given here in that S0. And we know that, again, the people who stayed the same, 85% of the people stayed with C, 80% of the people stayed with L, and 90% of the people stayed with. So because we want the opposite, we want the changes, I did 0.15, so 15% of 3,200. Yeah, so again, 85% of those 3,200 would stay with the brand, so 15% would be moving, plus 20% of 2,000, plus 10% of 2,800. So I was looking at the number of people who changed. When I put that into my calculator, I get 1,160. Using the rule, T times S of n complete the matrix below. Again, just to cut down the length of time this video is going to take, I just put in my transition matrix. They gave you order, so I put that into my CAS calculator and I multiplied it by S0. And then out came the values 1900 and 3040 for 1 mark. Consider the shoppers who were expected to buy Carmani olive oil in August. Okay, so what percentage of these shoppers also bought Carmani olive oil in July? Right, so in July, 3,200 people, that's what we started with. 85% of those would have stayed. 85% of those people would have stayed. So if I did 85% of 3,200, I got 2,720. That is the number of people who have stayed. But what we found out was that the new number of people was 3,060. So 2,720 out of those 3,060, yes, would have stayed, would have also bought. So when I multiply that by 100, I ended up to the nearest percentage of 89%. Write a calculation that shows Ohana olive oil is the brand bought by 50% of the shoppers in the long run. Okay, so they'd already defined matrix T, and I suppose if you wanted to, you could have written out matrix T and just written it to a really big power. For some reason, I always do it to the power of 100. I'm then going to multiply that because it wanted a calculation. And because it said the percentages show that 50% of the percentages, I decided to change this one here into percentages. How did I do that? Well, I know that 3,200, if we go back to the very beginning of the question, there, 3,200 people out of 8,000 people bought Carmani olive oil. Okay, so when I put that into my calculator, that gave me a proportion of 0.4. I could have written a 40%. When I repeated that with all the rest of the numbers, that gave me 0.25 there and 0.35. Multiplying that by in my calculator gave me 0.3, 0.2 and 0.50. And because the last one here is Ohana, that would give me the 50% that I was actually looking to it for, right? So 50% of the people I started with will have gone to Ohana in the long term. Further research suggests more shoppers will buy olive oil in the coming months. Again, this question was funky, right? Basically, they gave you R0, they gave you B, and they gave you T. And they basically said, if R2 is that, find the value of K. This is the way I did it. I quite literally used my recurrence relationship. So it told me to get to R1. I worked out R1 by taking my transition matrix. I multiplied it by R0, 2800, and I added 200, 100, and K. And when I spat that out of my calculator, I got something looking like, well, not looking like, it was exactly this, 2000 and k plus 3040. So when I put that out of my calculator, that gave me R1. Then what I did was I said, well, let's work out the value of R2. Again, I took my transition matrix, what I'd put in, I multiplied it by the value of R1, which I already had in my screen, and I again added on 200, 100, and k. And that came out with something fairly horrendous. It gave me 0.05k plus 3323, 0.05k plus 2075, I think my handwriting says, and 1.9k plus 3262. Well, they told me what R2 was, so then I used my CAS and I solved the value of R2, 333320253642, equals this matrix here, comma, k, and outcome a value of k of 200. Whew, that was a funky question. 5 staff members in Elena's office played a round robin. Now, I get it, guys. I saw this question and my heart sank. In fact, I left it to the end. Anybody who tried to do this was, yeah, if you found the way to do this, it was great. Me, I just decided to do trial and error. Right, so basically, I think you'll find that this was the one-step dominance matrix. So they were looking for the one-step dominance matrix. List all the information to complete the matrix. And I just did it by trial and error. And I was really, really lucky. In an exam, this was the one I would have left till the end, come back and then just done what I needed to do. I know a lot of people ran out of time. So 1, 1, 0, try that one again. 1, 0, 0, 1, 0, 0, 1, 1, I can't read, 0, 0, 0, 1, and 1, 0, 1, 0. So that was the correct answer for that one there. Well, that was the answer that I got. And again, when you add up those, you got 3, 3, 1, 1, and 2. And when you then take that and then do the second step, you do get the two-step dominance is the 5, 4, 1, 2, 4. That question was long. Networks and decision mathematics. So they gave you a room network there. The floor plan is represented by the graph below. On this graph, vertices represent the rooms and the outside area. Edges represent direct access to the rooms through the doors. One edge is missing from the graph. So when I looked at it, and thankfully this was quite nice, to go from A into F, there were 2 ways. So we already had that there. To get into B, from A into B, there was 1 way. And that seemed to be missing from my graph, so the one that I drew was there. What is the degree of vertex E? Well, vertex E has 2 things coming off it, so it is degree 2. Maggie hires a cleaner to clean the house. It's possible for the cleaner to enter the house from the outside area F, walk through each room only once, and finishing at F. So when I did that, I was looking at, so what did she do? She came into F, A, B, E, D, C, and then F. A, B, E, D, C, and F. So F to A, B, E, D, C, and F. And then looked it up because I had to look in my summary book myself. I never remember this stuff. What is the mathematical description for this? It's a Hamiltonian cycle. Ka-ching. Nice first question, I think. Basic, just whatever else. What is the shortest distance in kilometers between town G and town M? So they gave you all of this information. Now, what did I do? I just basically tried to find the shortest distance to each of the places. And you could have done Dijkstra's for this. That would have taken some time. And what I said was, well, if I follow this path here, how long is that going to take? That's going to take 26, 46, 76, 81. Right, so that's going to take 81, 26, 46, 56, 66, 76, 81. Is there a quicker way of getting there? Yes, there is. This way, which basically gave me 45. So I now know I can get to there quicker, 45. What about to get to N? What is the quickest distance to get to N? Well, again, I can take my 45, add on my 44, which gives me 89. Okay, but is there a quicker way of getting there? Yeah, well, 28 plus 42. So the 28 plus the 42 gave me 70. So there was 70. And again, working my way 45 around to here, worked out to be 45 plus 25 plus 30. However, if I did my 70 to get to there, plus my 16, it gave me 86. And again, there are other ways of doing this, I'm sure, longer and maybe shorter, but I am suggesting that the shortest distance is 86. Georgia plans to travel to Maggie's house. He will pass through all of the towns shown above. Okay, so I'm going to just delete all of this stuff here. And again, I just stumbled across this in an easier way. Because I basically went, well, he's got to go to here, and then down here, and around to there, and up to there, and then back, and down, and around. And to me, that just seemed reasonably obvious. And I'm so sorry if it's not. You may have bounced around a little bit, but it would appear the town that he's going to deliver a pass through twice is actually going to be town K. The network diagram below shows a local road network of town M. The number of the edges indicate the maximum number of vehicles per town. All right, determine the maximum number of vehicles that can travel from the entrance to the exit per hour. Okay, so we know coming into the network there are 1,500 vehicles. 700 of them can actually go that way. That's awesome. And 650 of them can go that way. Even more awesome. So the first thing I did was did 700 plus 650 just to make sure that it could take that capacity. So if I go back to my calculator, 700 plus 650, 1350. So that's okay. We can have the cards split. But by the time I get to here, only 680 of the cars can pass. So that now, 680. That's the maximum that can go there, 680. All right, so 650. Well, 650 can go there. How many cars can pass here? 300. So 300 can go that way. Let's see whether that's going to be possible though, because I need to work out, or I decided then to look at these two here and say, well, how many cars can come off of that node or vertex? Well, adding those together gave me 940. Okay, well, 680 are already coming from here. So that means that if I do 940 minus the 680 means that I've got to find 260 cars from somewhere. Well, that basically there can now only be 260, which means what? Well, if that's 260, how many cars can go along this section here? Well, 260, so I did 650 minus the 260 gave me 390. So that told me that 390 cars would be allowed to go along that road there. See what I'm doing? Okay. So I've now got 320 cars and 390 cars coming into this point here. Can the 840 take them? So let's see, 320 plus 390 gave me 710. Yes, so that value there is actually going to be 710. I already know 620 are going to move along there. So when I add together the 710 and the 620, I get 710 plus 620 gives me 1,330 cars. Ka-ching. The local council plans to increase the number of vehicles per hour that can travel from the entrance to the exit by increasing the capacity of one road and one road only. Complete the following sentence by filling in the box. Okay, we now know that we have limited our capacity here, haven't we? Right, so we know that theoretically speaking, we could make this an extra 130 cars. Yeah? Because we know we can squeeze them in. So where can we add those 130 cars? Well, as far as I'm concerned, we have capacity here because 390 extra 130 would fit down that road, but we've got to get them into that road. And so actually the most that's going to fit there would be A to D. So I'm going to suggest that we would need to change A to D so that we can fit the extra 130 cars into this section here to feed in to allow E to F to take those 130 cars. What should be the maximum capacity of that road? Well, the original capacity was 650. Add on the 130 gives me 780. And that question, thank you very much to a number of people for helping me with that one, really freaked my head out. Roadworks planned by the local council requires 13 activities to be completed. The network below shows these 13 activity and their completion times in weeks. What is the earliest start time in weeks of activity K? Okay, so having drawn on all of my delightful boxes, what am I now going to do? I am going to forward scan. Now I do mine not on the vertices, I do them on the edges. Thank you very much to a colleague for showing me this way. It just seems to make the float times work all the time. So what I ended up with, he said, forward scanning through this. And maybe I will just show you how I do it, he says, faffing around. What's going on here? Hold on, bear with me. Okay, so they both start at zeros. Let's just zoom in a little bit. Can it let me zoom in a little bit? It will. There we go. Is that still fitting on my screen? Yes, it is. They both start at 0. So that means that now this point here is going to be 6. So those two have to start at 6. This one here is going to get to 3. 3 plus 2 gives me 5. All right, so we've got 6 there. We had 5 coming in, so we chose 6 for being both of those. I should have done that one first, because that there would give me 6. That one there would be 5, choose business, which would be 6 and 6. 6 plus 3 gives me 9. That gets me to this point here. We've got a choice to come. So 6 plus 5 gives me 11. So that's going to be 11, and J is going to be 11. Obviously putting your boxes in the right place tends to help. What are we doing now? Let's change back. 11. We've got that's going to start at 3. I should have put that one on already. So when we get to this point here, we've got 3 plus 5, which is 8, or 11. So that is going to be, 5 plus 3 is 8. 11 plus 3 is 14. That one there is going to be 14. So K has to start at 14. That one there, and I is actually going to start at 11. I should have noticed that. Right, 11 plus 2 is 13. 9 plus 4 is 13, so that's going to stay as 13. 13 plus 5 is 18. That gives me 18 there. 11 plus 2 is 13, so I'm going to choose 18 to go in there. Plus the 1 gives me 19 to go in there. 14 plus da. So there we go. That was my forward scanning. Then when I backward scanned, so having done that, we can now answer the question. What's the earliest start time in weeks of activity K? It is 14. How many of these activities have a 0 float time? So again, what I did was I reversed the process. And when I did it, I got 19, I got 18 there, I got 13 there, I got 9, 6, 0, 1, 4, 11, 18, 11, 16, and 16. So we wanted float time of 0. That one, that one, that one, that one. Oops, I missed one. That's also a 6. That one, and that one. 1, 2, 3, 4, 5, 6, 7. There we go. 7 activities had a 0 float time. We didn't want you to list them. Okay, so we're now looking at a crashing question. Is it possible? It is possible to reduce the completion time of the activities given below. The reduction in completion time will incur an additional cost. Okay, completion time can be reduced by a maximum of 2 weeks. The overall completion time for the roadway. Okay, so it's going to make sense to try and choose the cheapest ones where we can on the critical path. So what I've done is I've done a dot where there are items on the critical path. So A, E, and L. So if I highlight those for the moment, A, E, and L are the ones that we can potentially change. It says that we can reduce the completion time to 16 weeks. All right. So if I can reduce my critical path by 3 weeks, then we're good. That's what we need to do, yeah? And try not to make a critical loss. So we need to reduce by 3 weeks. Now, it doesn't matter what I do to E, to be brutally honest, and I've already done this question, and it's up to you. So what I tend to do is just track all the way through the network and see what changes happen to each of those. Doesn't matter what I do to E. Not interested at all. It doesn't seem to make any difference. I could reduce A by 2 weeks, but what happens then is B to C becomes, I did that earlier, to make that 4 weeks, but then it means that this path here becomes 5, and that would become the new critical path. So that's no use to me. If I knock 1 week off of A, then actually that's going to be work. That still stays on my critical path. So I'm going to say A minus 1 week. E, as I've said, doesn't seem to make any difference. Well, what I can do then is look at L and see, well, can I reduce L by 2 weeks? So can that make that 3? And what I again do is I work my way through each of my networks. So I go, for example, here to here to here to here to here and say, well, what's the length of that? 5, 8, 9, 10, 11, 12, 13, 14, 15, 16. So actually that does give me 16 weeks. That's fine. But is there another way through that might give me longer? So again, I go through here and up here and down and along. And then I'd move my way along here and work my way around the other sections of that. And I do all of this in my head. That's the best way I can think of do crashing. And as it turns out, by reducing A by 1 week and L, by 2 weeks, we can effectively get what we need at the cheapest cost we can. So let me say A by 1 week, which is 140,000. L was 240,000. So 2 weeks of that, 240, add them together, gives me $380,000. So I reckon the answer to this one, $380,000. There we go. That was the end of networks. That was quite challenging as well. All right. I think probably one of the nicer crashing questions I've seen for a while. But again, if you're doing crashing questions, you just want to make sure that you keep the critical path. You look for all the paths through. And there are other ways of doing this question. All right. Geometry and measurement. The game of squash is played using a spherical ball that has a radius of 2 centimeters. Show the volume of one squash ball rounded to 2 decimal places is that. Well, I know the volume of a sphere is given by 4/3 pi r cubed, which is 4/3 times pi times my radius of 2 cubed. And again, not putting these in my calculator, that actually came out to be 33.51 centimeters cubed. Squash balls may be sold in cube-shaped boxes. Each box contains one ball and has a side length of 4.1 centimeters. Calculate the empty space. Well, the empty space, what I did was 4.1 times 4.1 times 4.1, which is the volume, and take away the volume of my sphere, which they gave me, which we'd already worked out as 33.51, which worked out to be 35.41 centimeters cubed. Calculate the total surface area of the square, calculate the total surface area in square centimeters one box. To do that, work out the area of one face, which was 4.1 times 4.1, and multiply that by how many faces there are. And there are 6, which when I put that into my calculator, gave me 100.86 centimeters squared. Retail shops store the cube-shaped boxes in a space within the display unit. The space has 17. So what was important to this question was knowing how many boxes you could fit horizontally, how many boxes you could fit going backwards, and how many boxes you could fit vertically. So when I worked this question out, I did, well, okay, I've got 17 centimeters, dealing with the horizontal first, I've got 17 centimeters, divided by 4.1, gave me roughly 4. It gave me more than 4, but I had to round down because I'm not going to be able to round up to get that extra squidge of a box in. So that gave me 4 boxes across. When I did 12.5 divided by 4.1, I got 3. So that gave me, I could get 3 boxes that way, 4 boxes that way, and then 8.5 divided by 4.1 gave me 2. And so in which case, when I did 4 times 3 times 2, it gave me 24 boxes. The game of squash is played indoors in a court on a front wall. A back wall and 2 side walls are shown in the image below. Each side wall has the following dimensions. The shaded region in the diagram above is considered part of the playing area. Calculate the area of the shaded region. This here is a trapezium. Okay, and if you know the area of your trapezium, if you know how to do that, you add together the parallel sides, you multiply by how far apart it is, and you divide by 2. So let's just flick my bit of paper over, and what did I get? So when you did that, I did 4.57 plus 2.13. I divided that by 2 and times it by 9.75, which gave me 32.66 meters squared. All right, trapezium, love, 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 love. Calculate the perimeter. Now, the perimeter, you had already got this distance here, that distance there, and that distance there. So you had to find that distance there. Well, welcome to Pythagoras theorem. So what I had to do was draw a line here. I knew that was 9.75. I could find this distance here by doing 4.57 minus 2.13, which gave me 2.44 meters. So I've got my triangle now. Actually, it probably makes sense to draw it the direction that you've got. So I knew that was 2.44, that was 9.75. So that length there, let's call it x, was given by the square root of 2.44 squared plus 9.75 squared. And that gave me 10.0506. The perimeter then, basically I just took that value, sorry, not x equals, let's actually make sense there please. So I know the perimeter was equal to 10.0506 plus all of those other edges, 4.57, 2.13 and 9.75, which gave me 26.5 meters. The two squash players are playing a match. Wei Yi and Bao are playing a match. The diagram below shows the lines on the floor. Wei Yi is serving from A, B. Okay, point A is 2.7. Okay, so there we go. A to C is 2.7 meters. C to B was 3.1 meters. We knew the angle was given here as 119 degrees, and it wanted to find the distance between the two of them. Okay, beautiful cosine question, or cosine rule question. So I know that x squared was equal to 2.7 squared plus 3.1 squared minus 2 times 2.7 times 3.1 times by the cosine of 119 degrees. Now, sadly, when I did this, because I teach specialist methods, I, like a muppet, left it in radians. Oh, that was annoying. So, but anyway, when I corrected it, that gave me an x squared value of 25.0157 ... which when you square root it, gave you the required answer of approximately 5 meters. Players will travel from around the world to a squash competition in New York City. They've given me 3 players. Okay, which players are from the Northern Hemisphere? Northern Hemisphere is those above the equator. So what I'm looking for is anything with a north in it, not a south, I want north. So that would basically give me Wei Yi and Oslam. The diagram below shows the locations of Shanghai, Durban and New York City. Lovely. The city of Istanbul, 41 north and 27 east is missing from the diagram. On the diagram, mark it with an X. Okay, so what we actually know is it's on the same circle as New York City, because that's 41 degrees north. And so I want it 27 degrees east. I know that Durban, because it's given in the question, is 31 degrees east. So I want it slightly to the left of that one there. So I put my X there. Job done. Okay, I quite like that question. Interesting, never seen it before. The flight from Istanbul, 41 degrees, to New York travels along a small circle. Assume that the radius of the Earth is 6,400 kilometers. Show the radius of the small circle. Okay, so I always tend to draw a circle here. There is my small circle. There is my radius of the Earth. So 6,400, I think I remember rightly. Yep. And I'm trying to find R here. I know that value there is basically equal to that 41 degrees north. Right, so that means that this angle here is 41 degrees north. So just having got that slightly bigger, that's 6,400, that's R, that's 41 degrees. So I can use my cosine rule to find that. And so I would end up with the cosine of 41 is equal to the adjacent over the hypotenuse. So R is equal to 6,400 times the cosine of 41, which gives me 4,830 kilometers, roughly. Calculate the distance that the plane travels between Istanbul and New York City. So Istanbul and New York City is basically... So Istanbul and New York City are on the same small circle. So if I was to draw that, then what I'm really looking for is looking for an arc length. Okay, so what do I know? Well, if I've got an arc length, this point here is Istanbul, this point here is New York City, and I'm looking straight down. Assuming this one here is where it is, I know that New York City was 74 degrees west, and I know that Istanbul was 29 degrees east. So I can now find this whole angle here to be 103 degrees. So how do I find the arc length? Well, I take the fraction of the circle, 103 degrees, divided by 360 degrees, and I'm going to times that by the circumference of a circle, which is 2 times pi times the radius. Well, I've already worked out the radius from a previous question. So when I put those in, so when I did 103 divided by 360 times 2 times pi times 4830, it gave me the value of 8683 kilometers. Wee and Camilla both arrive in New York City on Monday the 10th of January at 10 p.m. local time. Wee's flight left Shanghai on Monday the 13th of January at 8 p.m. local time. So what I think we do is we look at Wee, sorry if I've mispronounced that, yes. He left at 8 p.m. local time, all right, 8 p.m. local time. Well, we know the time difference, so let's actually deal with everything in New York time. All right, so 10 p.m. New York time, let's say it's 2200 hours. What am I going to do there? I'm going to add on the flight time, all right? So I'm going to add on the time difference of 13 hours. And then I'm going to subtract from that the time that we left from where he was, which was 2000 hours. All right, so when I do that, when I look at that in terms of times or what have you, that gives me a flight time of 15 hours. For Camilla, we had, again, 2200 hours. Add on the time difference of 7 hours. And subtract from that the local time of 4 hours, which gives me a flight time of 25 hours. So therefore the difference is equal to 25 minus 15, which is 10 hours. Hopefully that made sense, yeah? It just makes more sense to convert into all local times for New York and then work out what we're doing. Final module, graphs and relations. So the graph below shows the height in meters of a drone flying above a new housing estate over a 6-minute period of time. I'm fairly sure that drone's been flying over my house all the time. I've no idea why. For what length in minutes was the height of the drone at least 50 meters? So basically I drew a line across here. He says, yep. Let's angle it up a bit so that it actually makes sense. And then we know that it crosses, come on, be nice. We know that it crosses here and here, and so 5 minus 1 would give me 4 minutes. What was the average rate of change of the height of the drone in the first 2 minutes? Right, so the first 2 minutes, there's my first point, there is my second point. If I want the average rate of change, I'm effectively looking for the gradient. So I know the rise of that was 200, we know the run was 2, so therefore my average rate of change would be 200 divided by 2, which was 100 meters per minute. Christy sells a blocks of land at a housing estate. A pay is determined on the number of blocks she sells each week. Okay, the graph below clearly shows, or clearly doesn't clearly show anything. What is the minimum number of blocks of land that Christy must sell to receive $6,000 in 1 week? Well, the first time that she can receive $6,000 for that week is with that number of blocks, which when I read it off came to 6. John also sends blocks to land. He's paid $1,000 for each block that he sells. Write down all the values. Well, if John's paid $1,000, if he sells no blocks, he gets nothing. If he sells 20 blocks, he gets 20,000. And so ideally, what we wanted to do was draw a straight line between the two of those and then sort of see where it intersects. So if I now try and move this point, is it going to allow me to move this point? Come on. Yeah, there we go. And then I just highlighted all the points where they intersected and then just wrote them down. The number of weeks was 0, 3, 6, so 0, 3, 6, 11, 15, and 20. I think the thing that's going to trick people is this value here. I've got a feeling that people are going to have missed off that 0. John sells no more than 3 blocks of land for every 5 blocks of... Right, so again, the only way I can ever do this, because I hate inequality questions, Yeah, let X be the Christie and let Y be John. All right, so I know that John sells no more than 3 blocks of land for 5 of Christie. So there's 5 and there's 3. And what I tend to do is I tend to draw the line through there. Now, because it wants John to have less, what I'm going to do is look here. And I'm going to test that point there. So I know the gradient of this line, which is rise over run, is 3 on 5. So that line there is y is equal to 3/5 x. So if I now test this point here, I'm going to get, say that's 5, 2. What do I get? I get y equals 2 and 3/5 of 5 is 3. Well, 2 is less than or equal. So basically it is this section here I'm looking for, because we want John to sell no more than 3 blocks of land for every 5 that Christie does. So y is less than or equal to 3/5 x. I hate inequality questions with a passion. Liam is a builder constructing a community centre at a new housing estate. Oh, lucky Liam. The cost in dollars for Liam to work on site is given by that. The cost of 15 weeks of work on site is that. Show that the value of K is that. Okay, we can do that. So we know the cost. So we now know that 92,500 is equal to 10,000 plus K times 15. And when I put that, it says show that. So then I did 92,500, which gave me 82,500 is equal to 15K. Therefore, K is 82,500 divided by 15, which gives me 5,500. All right, so there we go. Again, it said show that. It was important to show that. Lamb's revenue for this job is R. So we've got cost and revenue. You need to be careful. Determine the number of weeks that Lamb needs to work on site to break even. So to break even, we know the cost must equal my revenue. So what I then did was I said, well, they got 6,500 per week, and we know that N is the number of weeks, is equal to the cost, which is 10,000 plus 5,500 times N. Putting that into my calculator and solving it gave me N was equal to 10. So basically, you've got to work on 10 weeks to be able to break even. I'm sure there's lots of ways of doing that. An equation for the profit P in dollars made by Lamb in terms of the number of weeks work on site N can be determined. Complete the equation by filling in the boxes below. Okay, so profit is cost minus revenue, right? So the profit is equal to the cost minus, sorry, try that one again, is revenue minus cost. Well, I now know the revenue was 6,500N. That was my equation for revenue. I'm going to take away my cost, and here was a trick again. Lots of people, I think, would have mistaken that there. That's why it had to be in brackets. So basically, when you multiply those brackets out, you got 6,500N minus 10,000 minus 5,500M gave me, that one there would be minus 10,123, and 6,500N minus 5,000 would give me 1,000. And there we go, 1,000 times N minus 10,000. Health and training services are, or sessions, try that one again, are held at the community centre. Let X be the number of sessions for each child, Y be the number of sessions for each adult, the total number of sessions given. All right, it takes, all right, blah, blah, blah. Explain the meaning of inequality number 5. So here is inequality number 5. Well, X stands for children, Y stands for, and 600 is going to be the number of minutes. Because it's talking about this 30 and 40, because we got a multiplier of 30 and 40, it's talking about the number of minutes. So I suggested the total number of adult and children sessions must not exceed 600 minutes. The graph below shows a feasible region. What is the maximum number of sessions for children each day? Well, to me, all I did was just work and look at what the maximum value was going that way. Now, the trick, I suppose, is it can't be there because you can't have 8.5 sessions because that doesn't make any sense whatsoever. So what I did was I chose this point here because that seemed to be the largest whole number of sessions for children, which when I read that off, gave me 8. The community profits from these sessions. Each session for children makes a profit of 45 and adults is 60. Determine the maximum profit. So what I said was, well, we can find my profit function as 45x plus 60y. Now again, whenever I do these questions, and I haven't taught linear for, well, I don't think I've taught the linear module for about 10 years. But I remember with these ones, I always used to rearrange it to give me y equals. So I've got 60y is equal to minus 45x plus p, or y was equal to minus 45 on x. Try that one again. Minus 45 on 60x plus p on 60. Now again, the only reason I'm interested in is I want that gradient there. So when I simplify that, I got a gradient of, oh, I keep doing this, I'm so excited to get to the end of the video. I've got the gradient of equals minus 0.75. So what did I do there? Well, what I'm going to do now is because I want to maximize my profit, I did a gradient of 3/4. So I did 3 there and 4 there. And making it longer if I can. I then did my sliding line, and I took it and took it and took it and took it, and oh, hold on a moment. It just so happened to coincide with that whole line there. Well, that's a good thing, because it means that this line here is my maximum profit function. Ooh, that's exciting. Determine the maximum profit per day from all health and training services. So again, I just chose a whole number of points on there. It just happened to be 8 and 9. So that was 8 and 9. And I just substituted it in. So I now know that I got, what did I get? 8 children. So 45 times 8 plus 60 times 9 gave me $900. Now again, list all the points in that feasible region for which this is maximum profit. We wanted to find all the integer solutions. So that was one of them. Then when I went through, there was another one. And there was my third one. And again, when you put all of those values in, you got $900. How do I know that? I checked. So the answer here was 0,15, 4,12, and 8,9. Ka-ching. And ladies and gentlemen, that was the end. Now I know again, lots of you ran out of time and lots of you found much of this difficult. There were some very, very tricky questions, and yes, they did ask them in another way. But hopefully these solutions have been helpful. Wishing you the very, very best of luck. Again, it's not over now until VCAA release the results. Please like the video. Please let your mates know about mathsguru.com and my YouTube channel, particularly people in Year 11 and your teachers. It will really, really help me out. Otherwise, guys, I look forward to seeing you in another video. You take care. Bye-bye.